Okay, to finish off this lesson then, because we ran out of time, we got to this point. This last section, I'm going to skip this guy. I'm just going to kind of do these three and call it a video. When will we get no solutions, and when will we get infinitely many solutions? Remember, both these cases are when the variables disappear, all of them. So when all variables disappear, one of these two is going to be the situation. If what you're left with is not a true equation, like 5 equals 7 or 2 equals 0, then it's no solution because it's not true. And then if it is true, like 0 equals 0, 1 equals 1, 2 equals 2, so if it is true, it's infinitely many. So that's how I remember it is, and n means that that statement is not true, and infinitely many is when it is true. That's kind of my silly way of remembering it. So I'm going to look at these guys and I'm going to number these. So look at the equations. What variable looks easiest to eliminate? And for me, it looks like the x's would be, I've got x, negative x, and that's a 2x, so I just need to double one of these, get rid of that. But I'm going to kind of fast forward to the problem, because sometimes you can, like if I picked 1 and 2 and I eliminated them, it actually works out okay. But if I do 1 and 3, that's when you see a problem. So if you did 1 and 2 and then tried any other combination, you would see things wipe each other out. So at some point it'll happen. I'm just going to make it happen on the first step. You don't have to do that. It's going to be by luck, I guess we'll say it that way. So if I take these two equations, I want to get rid of the x, I'm going to take this one and double it. Okay, or I want to rewrite this. So I got 2x minus 4y plus 8z equals 2. I'm going to double this one. Okay, actually I'm going to take it times negative 2. Let's say times negative 2. So I'm going to take this whole thing times negative 2. So negative 2x plus 4y minus 8z is going to equal 0. And look what happens here. They all wipe each other out. Okay, so and what I noticed was this is a 1 to 2 ratio all the way down for the letters. 1, 2, 2, 4, 4, 8. That's a 1 to 2 ratio. The constant, that doesn't matter right now. We'll use that to interpret. So if you ever see that, that means something's going to wipe out. It's one of these two situations. So I got 0 plus 0 plus 0, equals 2. That is not a true statement. So that is not true. That means no solution. Okay. So same thing on this one. 1, 2, 3. I'll just number them. I should have wrote down 1 and 3, where it came from. Look for some that have this, or problems, equations that have the same ratio. This one's a little bit more obvious. 1 to 2, 1 to 2, 1 to 2, or you can do 1, negative 3, 1, negative 3, 1, negative 3, 2 thirds, 2 thirds, 2 thirds. So any two you choose, it's going to work. I'm just going to do the first and the second. Now, the second equation, I'll just write it as it is. The first equation, I'm going to take times negative 2. So negative 2x minus 2y minus 2z equals negative 4. Okay? Wipes out, wipes out, wipes out. And here, in fact, wipes out too. So I get 0 equals 0. So all the variables are gone. It's one of these two. But that is a true statement. 0 does equal 0. So it is true. So it's infinitely many solutions. Okay? And then this last guy here, again, number them 1, 2, 3. And look for something that has the same ratio here. So same ratio. We could say 1 to 2. Nope, not 1 to 2 here. But if I go this route, 1 to 2, 1 to 2, 1 to 2, that's the same ratio. So I'm going to try to cancel these two together. So 2x plus 2y plus 2z equals 4. And I need to take this, times negative 2. So negative 2x minus 2y minus 2z equals negative 4. And again, everything wipes out. So all the variables being gone means it's one of these two situations. That is a true statement. That means it's this one. So infinitely many solutions. Okay, so if anywhere along that, it doesn't have to happen on the first step. It could happen later on too. It might be your second step, might be when you're combining the two equations with two unknowns. Like maybe when you get to this step right here, everything cancels out. If the variables disappear, it's one of these two. All the variables disappear, it's one of these two. And then you have to decide, is it true? Is it not true? Okay.